You may please start, sir.
Thank you, sir. Thank you, sir. Hi, hello, everyone. Yesterday, we had completed our chapter, and these were the 4, 5 questions that I had given you as homework. So, I'll be just discussing 2 of the questions before starting the new chapter that we were going to do today. So, so yesterday, this question, mod x raised to sin x, mod x raised to mod of sin x was given to you, and dy by dx at x is equal to minus pi by 4 was asked. Okay. So mod of x opens as x when x is positive and minus x when x is negative. So actually what happened is that I had to find the actual representation, or you can say the actual value of y. I needed to find what is my actual function y at that particular point. So when x is minus 4, my mod of x will open with minus x, right? It will open with minus x because x is negative value. Minus pi by 4 is a negative value, so it will open with minus x. And same way, when my sin x, it is negative, right? Minus pi by 4, fourth quadrant. So sin x is also negative. So mod of sin x will open as minus of sin x. Do you agree with this, everyone? Right? So my overall function y will be minus x raised to minus sin x. So you can differentiate minus x raised to minus sin x using what? Logarithmic differentiation. That's what you will do, right?
Ye-
Everyone?
Yes, sir.
Yes, yes, sir.
Okay. So all you needed to do was that find what the function is behaving. How is the function behaving? What is the actual definition of the function in the at the point that is given to you? Once you find that out, rest is just logarithmic differentiation. So did any one of you do this question and uh, get the answer? Anyone? Or maybe you can do it now. Is that possible? Okay. So fine. Like it was a really easy question, and I just think you can really easily do it, right? Okay. Now, like this question really was an important one. So I'll just write it down again. So y as a function of x has been given to you as x raised to x whole raised to x. Okay. And it is asking you the value of d2x by dy square plus 20. Okay. At x is equal to 1. So y is given to you as x raised to x whole raised to x, right? So since powers can be multiplied, it can be written as x raised to x square, right? Power outside the bracket can be multiplied, so it can be written as x raised to x square. Can anyone tell me how can I differentiate x raised to x square? How can I differentiate this thing? X raised to x square.
Log.
Yeah, logarithmic differentiation. So I take ln of y. So power will come down, so it will become x square into ln of x, right? Now I differentiate my left hand side, it will be 1 by y into dy by dx, right? Can you tell me what will be my right hand side? It will be x square into 1 by x, so that will be x plus 2x into ln x, right? So you have successfully calculated your value of dy by dx. That is y into, so y again I'll write it as this thing into x plus 2x ln x, right? This is my value of dy by dx. Now the issue is the one issue I've really faced is that I have got my value of dy by dx and not my value of dx by dy. Okay. See, in order to calculate d2x by dy square, what is d2x by dy square? Let us just revise. d2x by dy square, it is asking me. So it is d by dy of dx by dy, right? I need to differentiate dx by dy with respect to y. That is how I will get d2x by dy square. Do you all agree till here, everyone?
Yes, sir.
Yes,
Right?
sir.
Yes, sir.
This is how we get. Now the issue is, I know my value of dy by dx. Okay, I know my value of dy by dx. From that, can I get my value of dx by dy? from dy by dx, how do I get dy by dx? From dy by dx, how do I get dx by dy? Great. Reciprocal, right? Right? Because dx by dy is nothing but just the reciprocal of dy by dx. Okay, great work. But you can see over here, if I take d by dy, so it will become 1 by dy by dx, right? Something like this. So you can see that dy by dx, all the terms in dy by dx are in x. Okay, so dy by dx is in terms of x. How can I differentiate a function that has only terms of x with respect to a variable that is not there? Like, how will I do that? See, it is asking me to differentiate 1 by dy by dx. So dy by dx only has terms of x. Okay. And 1 by dy by dx will also only have terms of x. How will I differentiate such a thing with respect to y? Tell me, how should I do that thing? Like, isn't that confusing? Isn't that something that we are doing for the first time? Because dy by dx only has terms of x, and it is asking me to differentiate it with respect to y. Can anyone tell me how should I do that thing? Okay, so let us just take an example. So for example, you have a function f of y, okay, and it is asking you to differentiate it with respect to x. How will you do it? So you apply chain rule, right? What you do is df of y divided by dy into dy by dx. Chain rule. So this thing becomes f dash y, and this thing becomes dy by dx. So the same thing you will be doing over here. If the function does not have the variable you are differentiating it, no issue. You keep the variable outside. Fine. So it is 1 by dy by dx. How will I differentiate 1 by dy by dx? It can be written as the 1 by dy by dx derivative of 1 by f of x. Derivative of 1 by f of x can be written as minus 1 by f of x whole square, right? So minus 1 by dy by dx whole square. Okay. Into the derivative of dy by dx. Now again, there is an issue. It is asking me to differentiate dy by dx with respect to y. So what I'll do, I will again shift, multiply and divide by dx. So dx into dx by dy. Right? Basic chain rule, everyone. Got it?
Yes, sir.
Got it, everyone?
Yes, sir.
Right?
Yes, sir.
So this thing. So my first term is minus 1 by dy by dx whole square. Okay. Into. Can you tell me what will be this term? What is d by dx of dy by dx? What is this thing basically? What is the derivative of dy by dx with respect to x? Isn't it d2y by dx square? Right?
Yes, sir.
The
Yes, sir.
derivative of dy by dx. Okay. And what about dx by dy? How can dx by dy be written? So dx by dy can be written as 1 by dy by dx. Okay. So I have got my final answer as minus d2y by dx square divided by dy by dx whole cube. Okay. So I know my value of dy by dx. From this, can I calculate my value of d2y by dx square? So this means d by dx of dy by dx. Can I differentiate this thing with respect to x? Anyone? Can I differentiate this thing with respect to x?
Yes,
Yes.
sir.
Yes, sir.
What will be the derivative? What will be the derivative of this thing with respect to x? How will you differentiate? You have got two functions in multiplication.
Yes, sir.
So
Product.
yes, product rule. So you keep the second function as it is and you differentiate the first function. So the first function is x raised to x square. Okay. And I already know the derivative of x raised to x square is this whole thing. So I'll just copy this whole thing over here. So x into x square into x plus 2x into ln x. So I'll just put a square over here, right? This whole term is coming again, so I'll just put a square. plus now x raised to x square as it is multiplied by, now I need to differentiate x plus 2x into ln x. So 1 plus, how will I differentiate 2x into ln x? Tell me, what is the derivative of 2 times x into ln x? What is the derivative of x into ln x? Anyone? Derivative of x into ln x.
ln x plus 1.
Great. Are you sure? Okay, great. Oh, yes, correct. Right? Because x into, so if you differentiate ln x, it will be 1 by x. So that will become 1 and plus, when you differentiate x, it will be 1 into ln x. Correct. Value of d2y by dx square. And, okay. So if I input my value x is equal to 1, okay, just input your value x is equal to 1. Okay. So the value of dy by dx will be how much? Tell me. So 1 raised to 1, right? 1 raised to 1 square into 1 plus 2x into ln of 1. What is ln of 1?
0.
Natural log of 1. Okay. So dy by dx is 1. Now let us have a look at d2y by dx square. So it will be ln, so it is again 0, right? Ln part is again 0. So 1 into 1 raised
1.
to 1 square plus, right? 1 raised to 1 square into 1 plus 2 times of 1 plus 0. So 2 times of 1. This is, so this is 1 plus 3. So it is 4, right?
Yes, sir.
Okay. So your value of d2x by dy square is basically minus of d2y by dx square. So minus 4 divided by dy by dx whole cube. So 1 whole cube. So this value is minus 4. Okay. So it was asking me what is the value of d2x by dy square plus 20. So I have known that my value of d2x by dy square is minus 4. So minus 4 plus 20. So my final answer is 16. Fine. 16 is the correct answer to this question. So, okay, so like this was the only question. So what happens is you just need to keep this in mind, this thing that I've drawn over here. If you have a function with respect to a variable that you are not differentiating, okay. So for example, you have a function in terms of y that it is asking you to differentiate in terms of x. So what you do is you divide it by dy and multiply it by dy by dx. The same can happen in the other case also. So for example, it is asking you to differentiate a function that is in terms of x with respect to y. Okay. A function that has terms of x with respect to a variable y. So what you do is you can again do it. You divide it by dx and multiply it by dx by dy. So it will be f dash x into dx by dy. So that was it. And this is all about the chain rule that we currently need to know. And today we'll be starting with applications of derivative. Anyone, any doubts in the questions given yesterday? Okay, so if not, we'll be starting with applications of derivative. Just a moment. Okay. So till now we have been taking or finding out the derivatives of many functions. Okay. So generally we have talked about functions y is equal to f of x. And we know that what it represents. So basically what it is trying to tell me is how the function changes with respect to the variable, right? So it gives me the slope of the curve, right? dy by dx. dy by dx basically gives me the slope of the curve y is equal to f of x. Okay. So what happens in applications of derivative? So starting with the applications of derivative, the first thing that will start is rate of change of quantities. Okay. Rate of change of quantities. So for example, I give you a quantity, let us assume it to be some variable q. Okay. And what is happening is it is dependent on some variable r. Okay. And what is happening further is that r itself is depending on some variable, let us assume it to be t. Okay. And now I am asking you that what will be the rate of change of this quantity at a particular point when r has a particular value or when t has a particular value. So basically, I am asking you what is the value of dq by dt. Okay. dq by dt. I am asking you the value of dq by dt. So what is happening is f of, okay, it is f of r and r itself is q of t. So can I write this as d by dt of f of q of t? Right?
Yes, sir.
Right? In order to differentiate in the same terms, I will need to continue with this. So can you just tell me how will I differentiate this thing? How do I differentiate such a thing?
Chain rules, sir.
Chain rules. Can you tell me what will be the derivative?
F dash of q of t
Into
q dash t.
q dash t. Correct. Right? So just looking into the terms back. So this is basically f dash of r into q dash of t. Right? So can you just think what these two terms basically represent? F dash of r into q dash of t. What is the basic meaning of both of these terms? So the basic meaning of q dash t, it is really easy to think. See, first of all, dq by dt. dq by dt would mean the rate of change of q with respect to t. Okay. The rate of change of q with respect to t, right? This is what is meant by the derivative. So q dash t would mean rate of change of r with respect to t, right? Because r is q of t. So dr by dt is q dash t, obviously. It is dr by dt. Q dash of t is nothing but dr by dt. Or should we just write it directly? So I will write it in other words. So this can be written as df by dr into dr by dt, right? I can write it like this. So df by dr would mean the rate of change of f with respect to r. And this thing would mean rate of change of r with respect to t. So this is what we are going to do basically. So let us just try a basic example in order to understand this. Okay, rate of change of quantities. So what happens in rate of change of quantities is, so let us just assume that you have a circle. I'm not sure if you have done this in motion or not. So for example, you have got a circle, okay, and its radius at some point is 5 centimeter. Okay. So it is asking what will be the value of dA by dt. Okay. And this circle, the radius of the circle is increasing. It is increasing with time. Okay. So it is asking you that at when the radius is 5 centimeter, how is the area of the circle changing? So let us see if we can give it a try. Can you write the area as a function of the radius? Everyone, can you write the area of this circle as a function of the radius of the circle? Can you tell me what will be the function? F of r, what will that be equal to? How can area be represented in terms of radius?
Pi r square.
Great. Pi r square, right? Area can be represented as pi r square. So now it is asking me, what is the value of dA by dt? Right? What is the value of dA by dt? So can I just directly apply chain rule and write it like this? Right? Can I write it like this? Chain rule, basic chain rule? Or okay, just a minute. Let us start with easy question first. So in order, okay, so it is just asking you what is the value of dA by dr at r is equal to 5 centimeter. Okay, so just tell me the value of dA by dr. So we have written our function a area as a function of r. Okay, so can I calculate my dA by dr directly? dA by dr would mean d by dr of pi r square. Can you tell me what is the derivative of pi r square? What is the derivative of pi r square? Is it 2 pi r?
Yes, sir.
Right? 2 pi r, everyone. So now I just have a basic question to ask you. What is meant by this term dA by dr? Since we have done this thing many a times, what is meant by the term dA by dr? So dA by dr means rate of change of area with respect to which variable? Tell me, with respect to which variable?
R.
R, right? Radius. Because we are differentiating it with respect to R. So this is what it is telling me, right? So in other words, like if I begin to plot the relation between A and R, so dA by dr will give me what? Tell me, what will dA by dr give me? It will give me the slope of this curve, right? dA by dr will give me the slope of this curve at any point. So I choose any point. I know the slope of the curve, and that is how I will know what is the rate of change of area. Okay. How is the area changing with respect to the radius at that particular point? So if I substitute my value of R that's been given to me as 5 centimeter, can you tell me what will be my value of dA by dr? The rate of change of area with respect to radius. So I'll just directly substitute it as 2 pi into 5. So it will be 10 pi centimeter, right? Everyone?
Yes, sir.
Yes.
Okay, 10 pi. So, okay, so just one basic question I want to know from all of you. Is the answer dimensionally correct? Have you learned units and dimensions
Yes, sir.
in physics? You have learned units and dimensions. Is this answer dimensionally correct? Dimensionally would mean that is the left hand side, the dimensions of the left hand side equal to the dimensions of the right hand side? How will you check this? Have you done the units and dimensions of derivatives? Like, how do you check the dimensions of derivatives? Like, if you differentiate something with respect to a variable, how do you do it?
Sorry, sir, I don't know.
Okay. So like dA by dr is basically what? Like just go back into the first principle. Okay, what is the first principle of derivative tell you? The first principle of derivative tells you that if you represent your A as a function of radius, okay. So I am just treating my A as a function of radius, that is pi r square, okay. This thing is pi r square. So the dA by dr at any point would give me limit h tends to 0, A of r plus h minus A of r whole divided by h, right? Is this correct?
Yes, sir.
This thing is correct?
Yes,
Okay.
sir.
Okay, just a minute. So wait a minute, let me just change my variable. So we'll just assume this variable to be some variable x, okay? So this will become a of r plus h minus a of r. Okay, so you actually don't need to go in this detail. So like just assume that you have got 2 points on the curve, okay? So in order to calculate the slope of like what are we doing basically? If we are calculating the differentiation, if we are differentiating a function, what are we trying to calculate basically? We are trying to calculate the slope of the curve. Do you agree? We are trying to calculate the slope of the curve.
Yes, sir.
Fine.
Yes, sir.
That is what we are trying to do. So let me just assume this point to be some r1 comma a of r1. Okay. And this point to be some r2 comma a of r2 on this curve. If I join both of these points, can you tell me what will be the slope of the line segment joining both of them? What
A
will be
of
the
R2
line
minus
segment? A of
A of
r2
R2 minus
A
A
of
of
R2 minus
R1 minus
divided
whole by r2 minus r1,
by
right?
R1.
So if I just make my r tend to like if I just make my r1 tending to r2, so I will get this thing as dA by dr, right? This is what is meant by dA by dr, right? I am making the 2 points come very close to each other. This is what is meant by both dA by dr, right? I'm just making that both of the points come very close to each other. Okay, so for the time being, you can just forget this. Can you just tell me, you have got the slope, you have got dA by dr as a of r2 minus a of r1 divided by r2 minus r1. Can you tell me what will be the dimensions of the numerator and what will be the dimensions of the denominator? Dimensions of, what is the dimension of area? What is the dimension of a of r? A of r is pi r square. Okay. It is, what dimensions is pi r square? Area. Is it m0, l square and t0? Right?
Sir.
Right. And what is radius? Tell me. Radius is m0, l1 and t0.
Yes, sir.
Is this right? So can you tell me what will be the what will be the dimensions of the numerator? Anyone? A of R2 minus A of two areas being subtracted from each other. So obviously, like one area minus the other area, so obviously it will have the same dimension, right, of area.
Yes, sir.
And what about the denominator? It will have the same dimension as length,
T0.
right? So what will be the overall dimensions I'll get,
L L1.
right?
0
So
L1.
it is the dimensions of length. So am I getting the same answer over here also? 10 pi centimeter. Is centimeter does centimeter have the same dimensions? M0, L1, T0. Does it have?
Yes, sir.
Yes. So it's working fine. It's working fine. Not an issue for me. So in general, you can just remember this. Whenever you are differentiating some quantity, let us assume Q1 with some quantity Q2. Okay. So the derivative, okay, the derivative of Q1 with respect to Q2, the derivative, overall derivative will have the same dimensions as the Q1, dimensions of Q1 divided by the dimensions of Q2. You can just remember it in any generalized case. Q1 and Q2 can be any quantities you can think of, any physical or mathematical, any quantities. If you differentiate one quantity with respect to another quantity, the dimensions will also get divided. Fine. So you can just like see it very easily. Like you have got length, right? You have got displacement. What is the unit of displacement? It's L, right? L raised to 1, right? L raised to 1. So if you differentiate it with respect to time, what is the derivative of displacement with respect to time? You'll get velocity, right?
Yes, sir.
And what is the dimension of velocity?
L1,
L t
L.
raised to -1, right?
Yes, sir.
Yeah, so that is what is happening. You are differentiating it with respect to time. So your t raised to -1 is coming over here. If you differentiate it one more time with respect to t, the derivative of velocity, what is it? Acceleration.
Yes, sir.
And what is the what is the unit of that? What is the dimension of that?
L1 raised to 1
L1
into
raised
T1
to
raised to -2.
Yes. So you can check that your answer is compatible. And in any general case, it will always work. It will have to work because this is how the derivatives have been formed, right? So it will not go wrong in any case. Fine. Okay, great. So I hope you are fine with it and we'll just move ahead. So like this one was a really easy case. You did not need to apply chain rule. Now we will be doing one such case in which you will be required to use chain rule. Okay. So you have a cube. Okay. You have a cube. So it is asking you uh, the volume of the cube is increasing at 9 centimeter cube per second. Okay. The volume of the cube is increasing at 9 centimeter cube per second. So how fast is its length changing? Now you will need to use chain rule. Obviously, it is quite. So like, for example, you have a cube, something like this. Okay. Whose dimensions are increasing. Okay. So its length is increasing continuously. And it is given to you, the edge length is already given to you when the edge length is 10 centimeters. Okay. If the edge length is 10 centimeters, then it is asking you how fast is the length changing. So now you can just see length changing with respect to time. Okay. The volume is being given with respect to time. Divide by second, right? 9 centimeter cube per second. This means it is given with respect to time. So it is asking me how fast is the length changing with respect to time. So can you write volume as a function of your length? A, right?
A,
Can we do
sir.
it? A cube, right?
Yes, sir.
Now the issue is you know the value of dv by dt, right? Change of volume with respect to time, and you are required to ask dA by dt. What can I do in this case in order to involve both of these cases, in order to involve both of these quantities? What should I be doing to this equation? So if I differentiate this equation with respect to time, t, can I do that? I need to differentiate dv with respect to dt. So can I do it as dv by dA into dA by dt? Is this correct?
Yes, sir.
Okay. So tell me, dv by dt means rate of change of volume with respect to time. So can you tell me what is the value of dv by dA? Value of dv by dA? Derivative of v with respect to a. V is already a function of a. So what will be the derivative of a cube with respect to a?
3a square.
3A.
Yes, 3a square. Right, 3a square into dA by dt. And what is meant physically by the word dA by dt? dA by dt means rate of change of a with respect to time,
Yes.
right? Rate of change of a with respect to time. This is what is meant. So you know the value of dv by dt. Okay, you know the value of dv by dt. How much is dv by dt? 9 centimeter cube per second. Okay, it is given to you 9 centimeter cube per second. Okay, 3a square. A is already given to you 10 centimeter. So 3 into 100 centimeter square, right? Because you need to take the square of this into dA by dt. So dA by dt, tell me, what will be the value of dA by dt? Value of dA by dt. Everyone fast. So this will cancel out. So it will be 3 by 100 centimeter per second,
Second.
right?
Yes, sir.
So you can write it as 0.03 centimeter per second. It will work. Is this equation dimensionally correct? dA by dt is equal to 0.03 centimeter per second. Is this dimensionally correct? Who will tell me? Right? What is the dimension of A? A is its length. What will be the dimension of A? A will have the dimension of L raised to 0, right? And T has dimensions of T raised to 1. Oh, sorry, it is L raised to 1, right? What is the dimension of length, right? So instead of writing M0, L1, T0, I was just writing L raised to 1. Fine. So similarly, L raised to 0 and T raised to 1. So over here, I've got centimeter per second. Centimeter per second means L raised to L T raised to minus. Are both of them matching? Both of them are matching,
Yes, sir.
everyone. So it's dimensionally correct, right?
Yes, sir.
Okay. So we have got how the length will change with respect to time. Okay. Let us just try few more problems related to this. Okay. So let us try the same question in terms of area. Okay. So again, you have a cube whose overall surface area is increasing at 9 centimeters square per second. Okay. And when again the value of A is given to you as 10. So again, it is asking what is the value of dA by dt. The change of A with respect to time t. So can you write your surface area as a function of the length? Can you write your surface area as a function of length? Tell me, what is the surface area of a cube?
6a square.
Right?
Yes,
6a
sir.
square?
Yes, sir.
6a square. Great. Correct. Now the issue is, it has given me the rate of change of area with respect to time. So what has it given me basically? It has given me ds by dt, right? It has given me the value of ds by dt. So applied in chain rule, it can be written as ds by dA into dA by dt. Can you calculate the value of ds by dA? Everyone, the value of ds by dA. So you just need to take the derivative of 6a square with respect to a. Tell me, what will be the
12A.
derivative of?
12a, sir.
Yes,
12A.
right, 12a. So this thing can be written as 12a into dA by dt.
Yes,
Okay.
sir.
So again, it has given me a few quantities. It has given that ds by dt is 9 centimeters square per second and 12 into a. So it is 10 centimeter into dA by dt. So the value of dA by dt is how much? So this centimeter and centimeter will cut. So I'll be left with some centimeter per second, obviously. Okay, 9 by 120. If I cut it by 3, so 3 by 40. Right? 3 by 40. So the point over here is that by applying chain rule, a function that was not related, see, surface area was not directly related to time. You can see surface area is related to length, but length is changing with respect to time. So that is how the volume is changing, and that is how I'm getting out how fast the volume of the cube is being changed. Okay. So let us try one in a circular case also. Okay. So what is happening is you have this circle. Okay. So at a point, at any point that's been given to you, the radius of this circle is 10 centimeter. Okay. And the rate of change of radius with respect to time is 4 centimeter per second. Okay. 4 centimeter per second. So it is asking you what is the rate of change of area
Yes, sir. Any issue?
No, no, ma'am. Just my
Okay.
laptop turned off.
Okay, sir.
Okay, so I hope everyone is able to see my screen, right? Okay.
Yes,
I
sir.
hope my
It is
screen is
visible.
visible. Okay. So it's been
Yes.
given to you that the rate of change of radius with respect to time is 4 centimeter per second. Okay. And it is asking you what is the rate of change of area with respect to time. Can we do it? It is asking me what is the rate of change of area with respect to time. So obviously, can you write area as a function of radius? Tell
8
me.
pi
How can,
r square, sir.
yes, pi r square, right? I have successfully written my area as a function of radius. I know what is the relation between area and radius. So if I differentiate this thing with respect to time, if I differentiate this thing with respect to time, so what will happen? I can apply chain rule and I can write it as dA by dr into dr by dt. Can you tell me what is the value of dA by dr?
Sir, it's 2 pi r.
Great. So it's 2 pi r into dr by dt,
Yes, sir.
right?
Yes, sir.
So I already know what is the value of both of
dr.
these things, right? What is the value of, so this is 2 pi into r. R is how much? 10 centimeter,
Yes,
Yes.
sir.
right? So it is 10 centimeter into my dr by dt is 4 centimeter per second. So my final answer is 80, how much? 80 pi,
Centimeter.
Centimeter square per second.
right? Can you tell me what is the dimension of area? Dimension of area is L square, right?
Yes, sir.
Yes, sir.
What about T? What about T?
Second.
T is just T.
12t
So
raised to minus 1.
T.
yes, so it's matching, right? Both of the sides it's
Yes.
matching. Yes, it will have to match. Okay, great. So like these were one of the basic questions. Okay, fine. So just so let us just try one more. So it's been given to you that you have a cube whose volume is changing with respect to time. Okay. So instead of writing it, I can just directly write it like this. So the volume of that is increasing as 300, okay, 300 centimeter cube per second. Okay. Volume is changing. So if it's given to you that A is 10 centimeter, okay, A is 10 centimeter. So how fast is the surface area changing at that point? Can we do it? So obviously, can your volume of the cube, so it is a cube, okay. Instead of drawing the cube every time, I will just write cube. Can you write your volume as a function of your length, V of A? Can you write it as
Yes,
V of A?
yes, sir.
Tell me, how will you write?
A
How,
cube.
how?
Great.
It's A cube, right?
Yes, sir.
Yes.
Okay. So if I differentiate it with respect to T, tell me what will be the derivative of V with respect to time? So it will be 3A square into dA by dt.
Yes, sir.
Correct, right? I've just applied basic chain rule. So I already know the value of dV by dt is 300 centimeter cube per second into 3A square. So 3A square can be written as 100 centimeter square
100 centimeters.
into dA by dt, right? So 300 got cancelled. Can you tell me what is the value of dA by dt? Tell me. dA by dt is 1 centimeter per second.
Yes,
Right?
sir.
Centimeter square got cut. So
Yes, sir.
dimensionally also it is going correct. So I know what is the value of dA by dt. From this value of dA by dt, it is asking me the value of ds by dt, rate of change of surface area with respect to time. Can I write my surface area as a function of A? Yes, I can write it as 6A square.
Yes, sir.
So if I take derivative on both sides with respect to time, so it will be 12A into dA by dt.
Yes, sir.
So do I already know the value of A and dA by dt?
Yes, sir.
Yes. I know the value of A and I have calculated the value of dA by dt. So 12 into A.
To
A
10,
at that point is how much? 10
10
centimeter into dA by dt is 1 centimeter per
centimeters.
second.
Yes.
So 120 centimeter square per second. This is my final answer of dA by dt. Right? Got it,
Say
everyone?
d by dt.
Oh, sorry. Yeah. ds by dt. I written ds by dt. Okay, fine. So yes, correct. So now let us just try one question in which you have more than one function. Okay. So more than one function, more than one variable. So let us give it a try how you can do it. So for example, you have a quantity q, okay, in which you have got two quantities, okay, two functions. So q is related to two variables. You can say two variables, x and y. Okay. Q is related on two variables, x and y. And both x and y are somehow related to variable t. So if you are asked dq by dt, so you will need to differentiate dq by dt by applying chain rule. Okay. So, okay, so just tell me one small thing. Generally, till now, we have taken y to be a function of x. Okay. We have taken that y has some relation with x. Overall, in such a case, is there a relation between y and x? Okay. So over in this case, y and x are independent, completely independent. Y and x are just two normal variables. They have got no relation between themselves. Okay, x and y have got no relation between themselves. They only have a relation between t. So fine, let me just give you a direct example in order to show. So like you are just adding one variable, nothing new is happening. So let us just directly try a question. Okay. So you have been given a rectangle. Okay. So the length is x. This thing is x. This thing is y. Okay. So the length of the rectangle, the rate of change of length with respect to time is 3 centimeter per second. Okay. And the rate and the width y, the rate of change of y with respect to time is 2 centimeter per second. Okay. So when x is 10 centimeter and y is 6 centimeter, so it is asking you the rate of change of perimeter. Rate of change of perimeter with respect to time. So can you write your perimeter in terms of x and y?
2 into
Can you
x
write your
plus y.
perimeter? Yes, great. 2 into x plus y. Right? So over here, what you're doing is you have a quantity P. It's related to two quantities, x and y. And x and y both are related on a third quantity, T. But x and y themselves are not related. X and y themselves are completely unrelated. Okay. They have got no relation between themselves. So can you differentiate P with respect to time? Tell me, how will you differentiate x plus y? So this can be written as dx by dt plus dy by dt, right? I've just differentiated both of these things with respect to time. Is this correct?
Yes, sir.
Tell me, is this correct? Right? So all I need to do is just put in the values. So the values are already given to me. Can you tell me what will be that? So 2 into dx by dt is how much? 3 centimeter per second plus
2
2
centimeter.
centimeter per second. So my final answer is 10 centimeter per
10.
second.
Yes, sir.
Right? See, adding two values of the same dimensions does not change the dimension. You know that, right? If I'm adding 3 centimeter per second plus 2 centimeter per second, that's allowed. And the result will also be in centimeter per second. Okay. So that is why dp by dt, perimeter is in, tell me, perimeter is also in centimeter and time is also in centimeter, is in second. So centimeter divided by second, I'll get my answer in centimeter by second. Fine. Let us try one more case. So now it is asking you what is the value of the change of area with respect to time. So this one is a little bit special for today. So can you write your area in terms of x and y? Can you represent your area in terms of x and y? Who will tell
Sir,
me?
x into y. X
Yes, x
into
into
y.
y. Great. X into y. Great. If you to differentiate your area with respect to time, how will you do it? So it is product of two functions. Do you agree? See, A is
Yes.
dependent on two functions, x and y, both of which are dependent on t. So if I ask you to differentiate, so you will obviously need to apply product of two functions. So if you differentiate the first function, keep the second as it is, plus
dy by
plus
dt equal
Y.
dt.
to x.
right? Do I
Yes,
know
sir.
all of these values? Yes, I know already. I already know what are the values. So x is given to me as 10. Okay, it is given to me as 10 centimeter. Okay, and dx by dt is 3. So 3, 2. Okay, this thing is 2. Just a minute. This thing is 2. This thing is 3. And this thing is how much? 20, right? 6. Okay, 6. Can you tell me what will be the dimension of the overall answer? Just for the time being, can you just tell me what will be the dimension of the overall answer?
T raised to 1, T raised to 1. m raised to 0.
Just unit. Tell me the unit.
Centimeter square per
1 second.
second.
Yes. How did you tell it? Did you multiply both of these and get the answer, or you can just look at the left hand side? So in the left hand side, you have got dA by dt, right? You have got dA by dt. So area has L square. So centimeter square divide by t time second. So tell me, 18 plus 20. 18 plus 20 is how much? 38,
Yes, sir.
Yes.
right? So that's your final answer? 38? Okay, correct. 38 is the correct answer. Okay, fine. Let us just try one more last question before going today. So you have been given the equation of a curve. Okay, 6y is equal to x cube plus 2. Okay, this is a function that's been given to you. So it is asking you find the point on the curve. Okay, so basically what is happening is you have this xy plane. Somehow the curve has been plotted. Okay, something like this maybe. And a particle is moving on this curve. Okay, particle is moving on this curve with respect to time, obviously. If it is moving, it will move with respect to time. So it is asking you to find a point on the curve at which y coordinate is changing 8 times as fast as the x coordinate. So it is asking you to solve dy by dt is equal to 8 times of dx by dt. And it is asking you to find what is the point on that curve. So you have got 6y is equal to x cube plus 2. If I differentiate both sides with respect to x, with respect to t, so it will be 6 into dy by dt, right, is equal to. Can you differentiate the right hand side and tell me what will be the derivative with respect to t? The derivative of x cube with respect to t. Tell me. Derivative of x cube with respect to t. No one. Chain rule. Now tell me. 3x square into dx by dt. Correct? Everyone?
Yes, sir.
Yes.
Okay. So 3x square into dx by dt. So I got this equation. And it has given me one more condition, this thing, that dy by dt is 8 times of dx by dt. So what I'll do is, in place of dy by dt, I'll just directly put 8 times of dx by dt. So dx by dt got cancelled. Can you tell me your value of x square is how much? What is the value of x square? 6 into 8. So it's 16, right? X
Yes,
square
sir.
is 16.
Yes,
So
sir.
your value of x is plus minus 4, right? If your value of x is plus minus 4, so your first point will have the coordinate x is equal to 4. Your second point will have x coordinate x is equal to minus 4. Can you find out the y? When x is equal to 4, how much is the y? So you will have, tell me. So what is it? So 64 plus 2, 66. So it is 11, right? 64, 64 plus 2 is 66 divided by 6, right? So what about the other case? Minus 4. So 2 minus 64. So it is minus 62 by 6 or minus 31 by 3. I'll just write it as minus 31 by 3. Just calculations. So your first point will be 4 comma 11. Your second point will be minus 4 comma minus 31 by 3. Fine. These are your 2 points. So I just want you to be doing one small question. Okay, just one small question. In this question, like you have been given a cone. Okay, you have been given a cone, and it is asking you what is. So you just have this radius r. The radius r is changing, and the height h is changing. Okay, the value of dr by dt and the value of dh by dt have been given to you. And obviously at some particular values of r and h. So it is required for you to find what will be the value of dv by dt, where v is the volume. So can you just write your v as a function of r and h? Do you know what is the relation? What is the volume of the cone in terms of radius and height? It's 1/3 pi r
Yes.
square h. I hope all of
Yes,
you know
sir.
this. Will you be able to differentiate this thing with respect to t and get me what the answer will be in terms of dr by dt and dh by dt? Fine. So this is your homework for today. I want you to differentiate the volume of this thing with respect to time and tell me what will be the expression for dv by dt in terms of change of radius and change of height. Fine. So that's it for today. Okay. I hope you will be able to do it. It's not tough. Fine. So that's it for today. Okay. Thank you. Ma'am, can you?
Yes, so you're done, sir?
Yes, yes, ma'am.
Okay, sir. Yes, students, you can join the next session. Join the next session.